This next video is a video of the solutions for problems 21 through 23 in your genetics homework packet. So these problems are our sex-linked problems. So problem number 21, a normal man marries a woman with normal vision. They have 5 children and one of the boys is colorblind. So we have the colorblind child, so we can put that in the Punnett square first. The mother has to be heterozygous. She has to be a carrier because she passed down the recessive allele to her son. The other allele that her son got was the Y chromosome from the father. So if a son is colorblind, it means his mother must be at least a carrier of the colorblindness trait. Now, the father, it says, is normal for vision, so he would be X big C Y. The mother has to be a carrier again because we knew the child, the son, was colorblind. So when we fill in the rest of this Punnett square, we can see that no, none of the girls can be colorblind. If the father has normal vision, none of his daughters could be colorblind because they would always get the dominant normal vision allele from the father. If a daughter were to be colorblind, she would have to have a colorblind father and at least a mother who's a carrier. So in this next problem, we have a colorblind man and they have 5 children and one of the boys is colorblind. Now in this case, it's tempting to think, oh, he could have gotten this allele from his father, but he got the colorblindness allele from his mother because he got the Y chromosome from his father. The mother only has X chromosomes, so the Y chromosome always comes from the father. So in this case, the father is colorblind, and the mother is a carrier for colorblindness because her son is colorblind. So there is a chance to have a colorblind daughter, as you can see. In order for a girl to get this colorblind phenotype, her father has to be colorblind and her mother has to at least be a carrier. Of course, if the mother had been colorblind and the father had been colorblind, all of their children would have been colorblind. So in this case, there is a 50% chance of their daughter being colorblind and a 50% chance of sons being colorblind. Question number 23. Hemophilia, a sex-linked recessive trait. Hemophilia is a sex-linked recessive trait that's carried on the X chromosome. A female carrier of the rare blood disease does not express or suffer from the disease that prevents the blood from clotting normally. So, in problem 23, we have a female who is a carrier of hemophilia, and she has offspring with a male who does not have hemophilia. And if we fill in the Punnett square, the percent of the female children that would be normal would be 100%. You have to realize that carriers are phenotypically normal. 50% of the females would be carriers of the disease and 0% would suffer from the disease. Now, if we look at only the male children, 50% would be normal for blood clotting, 0% would be carriers of the disease, and 50% would suffer from the disease. One thing that you have to realize is that if you are a hemophiliac, you're not considered a carrier of hemophilia. A carrier is someone who can pass it down but doesn't express it. So, can males be a carrier of a sex-linked gene? No, males only have one X chromosome. If their X chromosome has the mutation, they will have the disease. So a carrier is someone who can pass down the disease but does not have the disease. It's very tempting to consider those who have the disease to be carriers, but they are not.